Hi, I'm Zen, a software and AI engineer, and I've brought AI solutions from proof of concept all the way to production. I'm here to teach you how to inject documents for your AI to make it smarter and more accurate, like a pro. So specifically, we're going to be talking about vector databases, which is a concept that you can really use to productionize your AI solutions and really bring it to the next level. Effectively, to understand what a vector database does, I want to give a brief introduction about what it means to actually inject documents into an AI system. So effectively, what we want to do is we want to translate your documents into numerical representations, and these are called embeddings. With these numerical representations, we can perform math to find the most relevant pieces of documentation to answer a user's query. So, to kind of illustrate that, let me walk you through the code that we actually have created for a previous video on the channel, where we are doing this exact same thing, but then we're doing it locally in memory. So let's have a look at the current code. If we look at the code base that we have here, which is readily available in the video description, then I'm just going to ask this system a simple example question. When did I last eat a chicken dish? And it's able to answer this question because it has access to my markdown diaries, specifically in the form of embeddings, which are stored locally on the disk. However, this is limited, right? Because if I have gigabytes of diary entries, then this is going to become very difficult to keep track of. So we will need to create a vector database. There are many different providers that have a vector database nowadays. And one of the providers is Microsoft Azure. You can use Azure Cosmos DB to create a vector index. But there are even other options within Azure itself, like PostgreSQL with a vector plugin. Now, I'm not saying that Microsoft Azure is the be-all and end-all of vector indexing. There are many other providers, and there's even a lot of AI startups that have optimized vector databases for specific use cases. It can be very difficult to find the perfect provider for you, so if that is a question you struggle with, let me know in the comments below. But for now, we're going to just assume that we're going to be using Microsoft Azure. If we go to our browser, you can see that I've already got the Microsoft Azure portal open, and I'm just going to go and create a new Cosmos DB account from scratch, so you can follow along and we can see what it actually does in practice. So in here, I'm going to create a new DB. And traditionally, Cosmos DB is a NoSQL database. So I'm going to create a Cosmos DB for NoSQL account. And let's just call it vector demo recording. Vector demo live. There we go. That should be available. We'll go for West Europe. And in this case, I'm going to go serverless. But if you have not actually deployed Cosmos DB before, it's good to know that you can select a free tier as well. Because I'm not going to use this account that much, serverless is also practically free, so it's fine. And then I'm just going to create it with the default settings. That will work for now. So I'll click on create, and while it's creating, let's just actually have a look at the code to see what's changed with the old method versus this new method that utilizes the Cosmos DB instance. Looking at our VS Code again, I want to just illustrate that our old code is in here, AskGPT old. And this code loads in the embeddings locally based on the embedding files that are in this folder. And then what it does is it finds the most relevant entry by using the concept of cosine similarity to compare documents basically in memory. Again, this works if you have a small amount of documents. But if you have a lot of documents, this is going to get out of hand, right? So what we want to do is we actually want to delegate this task of comparing the documents to Azure Cosmos DB. If we have a look at our new script, AskGPT, it works a little different. First of all, there actually is no load embedding script because again, those are already stored in Cosmos DB, right? So all we have is this find most relevant entry method. In this case, Azure Cosmos DB has a SQL-like syntax. We select top N, from the C, which is a specific container that we create for the purposes of storing these diary entries. And we call a special method vector distance, where you can say that you want to compare the embeddings of the content, so in this case, the diary entries, with a specific query embedding. And this query embedding is the embedding of the user question, right? So you have to create an embedding out of the user question, and then compare it against all of those other documents. Instead of having to write the method ourselves though, we just give this SQL-like query to Azure Cosmos DB, and we can even specify how many documents we want to have returned. Then the query executes and it's going to return the top documents for our query, which is very nice. However, before we can actually do this, we need to fill up that new Azure Cosmos DB account with the embeddings. And for that, we've got this script, diary to embeddings. So what does diary to embeddings do? It does a couple of important things. First of all, I'm assuming that the Cosmos account is completely empty, so it will create a database for us. But crucially, it will also set up the indexing policy. It will basically tell Cosmos DB that we want a specialized vector index to be created under keys that have the path /embeddings. So again, because it's a NoSQL database, you can also just store regular database objects and entries, but we want to have a specialized vector index for keys that are called embeddings. And then we further specify what kind of embedding we have. In this case, it's a float32 embedding. We want to use cosine as our distance function, which is a sensible default. And we want to set the dimensions to 1336. This has to do with the fact that the OpenAI embedding model that we use simply has this many dimensions, but that might vary depending on the model that you're using. But of course, Cosmos DB doesn't do the embedding for you. You have to still create the embedding, and then Cosmos DB handles that. There are services where you can just upload your document and the embeddings as well as the similarity comparisons are handled for you. But in Cosmos DB, you still have to create the embeddings yourself. And if we look at our embeddings files, you can see that they are quite large, but you also see that there are indeed 1,536 entries here. So that corresponds with the amount of dimensions that I'm basically entering in here, right? So that checks out. If we scroll down even further, you will see that when the diary entries are processed, it will create a new document for all of them. And of course, we can also just store the content in plain text. That's what we are doing here. But then, of course, we also store the embeddings under the key embeddings because that's the vector index that we've set up on the Cosmos DB side. So with that being said, let's check out the Azure portal and see if our account has been created. Our account has indeed been created, but it looks a little bit sad and empty right now. So let's go ahead and fill it up with a database, a container, and our embedding files. Now, it is good to know that I actually added environment variables to my code. If we go to our code, you will see that there's a .env.example file. If you are following along, this is the moment that you should fill in these 3 environment variables, right? I've done this for us already so that we can proceed. And what we're going to do first is run this diary to embedding script. So we're going to do Python diary to embeddings. And instead of saving those embeddings to local files, it's actually going to send it straight to Cosmos DB. Aha, but hold on. It seems that the capability to create a vendor index is not yet enabled for our account. So I'm recording this at the moment when it's still a preview feature. So if we go back to our browser, you can see that there's actually documentation from Microsoft describing that this is a preview feature and that you have to enroll for it by executing this update command. So I'm going to go to the Azure Cloud Shell just because it's convenient. And I'm going to go ahead and just copy paste that command and simply replace these 2 parameters. So we have vector demo live together with the resource group that was already created beforehand, which is called vector demo. So again, let's be patient and wait for this to complete and then try running that script yet again. All right, fantastic. It looks like the command has succeeded, which means that now we should be able to create containers with a vector index. Now I'm going to go back to VS Code and rerun that same command, and hopefully this time it will work. So let's go ahead and do that. And here we go. It's creating that container, and it's actually passed on all the embeddings for the markdown files. Let's make sure that's actually true. Going back to the Azure portal, I'm going to refresh this view, and we see here that there's a diary embeddings container, which has all of those diary entries as its items. We have an ID, which is just a file name. Probably should be using a UUID for that, but it's fine. This works for now. We have the content, which is just the plain text content. We have a category as well. And then we have that embeddings array. Now again, because Cosmos DB is a NoSQL database, you can always pass this embeddings array, but you should really enable the vector index functionality to get the ability to query over those embeddings very simply and compare them to user inputs. You don't get those functions if you do not enable the vector index. What's interesting about using Cosmos DB for this is that you don't only have the ability to store embeddings. Clearly, this is a general purpose database as well, right? Because I can store the content and I can store the category. And that's what I like about this specific vector database, because it also serves as just a regular old NoSQL database. So you basically have the best of both worlds. You can use this for document similarity search, but then also use this document for any other purpose that your application might have, which I think is pretty nifty. Now that being said, let's go back into our code and run this Ask GPT script, which again uses this SQL-like query to do the similarity comparison instead of doing that locally in Python itself. So we're going to call that script with the same question we had before, and then let's see what happens. So in this case, we see here at the top that it has two most relevant entries, which I specified in the function arguments as the default. And it's important to note here that both of these entries have very, very similar similarity scores. They are both 7, 6, 2, and in this case it's 3, but here it's 7, 6, 2, 6. So you can see that the scores are super, super similar to each other. What's actually interesting is that if you look at the content of the diaries, then the actual diary with the answer, which says we had a family barbecue with grilled chicken, has a slightly lower similarity score than the other document. So in this case, if we only took the most relevant document according to the similarity search, we would actually have a problem because that wouldn't contain the answer, right? So this illustrates that it is quite smart to take the top 3, top 5, maybe even top 10 documents, if that's possible, to answer a user's question, because similarity search is pretty difficult to always get right, especially if the user question is very short. Now, of course, you might be thinking, well, why is this search so difficult? I mean, I'm clearly mentioning chicken here, but the problem is that similarity search is much more context dependent. So ideally, users actually describe their questions in a little bit more detail. But of course, in most cases, users converse with AI systems if it was like some kind of search engine. So you shouldn't rely on users to ask the most detailed questions. Instead, just make sure that you retrieve more than at least one most relevant document to increase the chances that you can actually answer the user's question correctly. And in this case, because we did at least include 2 documents, GPT does respond that I last ate a chicken dish on the 11th of June, 2023. So compared to the original solution, which did the cosine similarity in Python itself, we have a pretty similar result. However, this is of course a lot more scalable because we have a vector database behind it that can potentially handle hundreds of thousands of documents. So if this was very helpful to you, make sure to leave a like. And if you want to learn more about how to bring AI from proof of concept to production, of course, you can subscribe.